Good morning, everyone. Thank you for coming this morning. This morning's session is going to be leveraging TypeScript in cross-functional development teams. My name is Richard Brooks. This is my colleague Aaron McGee, and we work for a small company in Auckland called BKA Interactive. We're a website development company, and more recently we've been developing more application-based websites, leveraging front-end development much more than traditional websites. So what we're going to show you today, hopefully we're going to show you how we use TypeScript, how TypeScript can help us to build better and more complete web applications, how TypeScript can help us to enable the workflow between front-end development, back-end development, and how we can use model generation with TypeScript to bring those things together. Aaron?
Thank you for that introduction, Richard. So my name is Aaron McGee. I'm a colleague of Richard's, as he's mentioned. I'm a full-stack developer at BK Interactive, and later on in the presentation I'll be introducing to you the concept of model generation, how to use it inside your applications, and how it can enable you to write more correct and better integrated applications. So bring it back to Richard.
Okay, so as we said, building larger applications requires the use of JavaScript, or we tend to use JavaScript. JavaScript, as we know, has some inherent difficulties. JavaScript is fundamentally quite difficult to build large applications using JavaScript for a number of reasons. It has a very verbose function syntax, typically weak typing especially. We all know about automatic type conversion, which can cause us problems, and the often poorly understood this behavior, which makes developing larger scale applications with lots and lots of code a little bit awkward for us.
Reminds me of a joke, actually. I heard earlier. It goes like this. There is a guy, he's a JavaScript developer, and he's getting really frustrated, and one day he's like, oh my gosh, I hate this. And he just couldn't remember what this he was talking about. Anyway, back to Richard.
Very good, very good. Yeah, so however, we're bound to JavaScript. If we're going to build these application-style web apps, we're bound with JavaScript. We don't have a choice other than to use that, basically because the browsers will not allow us to use anything else. That's our tool that we must use, and we'd like to begin by looking at one of the tools that we can use to help us to use JavaScript, to help us to use it more efficiently, and we're going to suggest that may be TypeScript. So I'm going to briefly introduce TypeScript, and I'm going to go through a couple of some of the basic features of TypeScript before Aaron gets on to the more involved model generation. So TypeScript, what can we understand about TypeScript? TypeScript is essentially a superset of JavaScript. So JavaScript itself is perfectly valid TypeScript. TypeScript just allows us it adds some what we're calling syntactic sugar, some syntactic features that help us at the time of development, at the time we write the code, to introduce some strong typing, to flag up any errors, give us like compilation time errors in JavaScript. And using TypeScript, we can actually so a build will fail if there are errors in our JavaScript. And that's obviously really handy for particularly continuous integration, or those of you using that, we can stop a build at the point when we've identified some front-end errors, as opposed to having to wait until we actually got it out and start exercising that code in the application itself. So I'm just going to look at a couple of the, just briefly take you through some of the basic types that we get to use, some of the things that it introduces. And here we'll see just some very simple variable declaration. Looks almost the same as JavaScript. All we're doing is declaring those variables having a type. So a Boolean, a number, a string, or we also have the special case of the type any. So we may use that if we don't want to lock down the particular type that we're going to use, and we can put anything into that any type. When we compile TypeScript code, we get JavaScript code. And as you can see from this, is compiled from the previous slide. And as you can see, all that's gone, that syntactic sugar, if you like, that the additional helper features that we get at time of development have been taken out. And we now have JavaScript. We can modify this, we could do that, but if we were to modify directly in the JavaScript, of course, we lose that. So the key is that we develop in TypeScript, compile down to JavaScript, and so forth. So just moving on to one of the other types that we have there, also adds some enums, which are familiar to back-end developers, just another tool that we can use, and able to bring those into JavaScript. So just there, a TypeScript declaration of an enum, and see how that compiles down to JavaScript. Obviously, JavaScript, we don't have that in there. Aaron?
Really interesting note about this, actually. Notice the syntax there. It looks very confusing, but these are actually associative arrays. TypeScript treats enums as associative arrays in JavaScript. So what that means is that you can actually pass to that associative array the name of an enum, and you get back its integer value, or you can pass the integer value, you get back its name. And this is something to keep in mind when you're using TypeScript, because it can be extremely useful when you're manipulating enums. Sorry, go on, Richard.
Thank you. Yeah, the next thing we'll just very quickly mention, arrays. Again, just that type safety. So if we, in our code, we expect to have an array, we expect to use some of the functions or properties of a JavaScript array, we declare something as being an array, and that means that we can't just accidentally put something else into it. So you see just a couple of potential ways that we can var up an array in TypeScript. Declare it as an array of numbers. Second one just uses generics. Generics is also an additional feature of in TypeScript, so we can generically define that array. They both compile down to just a standard array. And if we try and use that, we try and use something, try and put something into that list now, which is not an array, a different type of object, we'll get a compile time error. Another feature of TypeScript, interfaces. Interfaces, again, allowing us to define the shape of an object that we might expect. So we can use an interface to define, in the first instance, just an object. So in this case, this function expects an object of a particular shape. In this case, something that implements the I label value, which it just accepts an object with a single property, which is a string. If we were to try and put an object, pass an object into our function print label that didn't conform to that interface, we'd at that stage get an error, and we would flag up to ourselves, we'd know there's an error, we wouldn't be able to compile, and we'd fix that problem. Interestingly, if you look at the bottom, second to bottom line of code, we can pass something into, pass as that object. It has some additional properties. It just has to have a minimum of what we've defined in the interface, but we can pass additional things. Should we just try and pass the size, at that stage, we'd see an error. And we'll just have a look at what that compiles down to.
Very interesting, actually. If you could go back quickly.
Sure.
Very interesting is that the interface we defined in the previous slide, and I'll just go back again so you can see the interface again. We wrote the interface into TypeScript. If you go back into the corresponding JavaScript, there is no interface. The interface gives us the benefit of type safety, but doesn't actually add anything to our front-end application. So that's something to keep in mind for later.
Thanks. As I said, so the previous example just defined the shape of an object. We can also define the shape or the feel of a function, as we've done here in this quick example. So we're just defining that our search function is going to accept 2 strings, and it must return a Boolean. And if we divert from that, if we try and do something else, try and call that function with something else, at that stage, of course, we'll get JavaScript errors. And as Aaron pointed out earlier, the interface is gone. So we just have the function in that case. There's no JavaScript representation of the interface. Finally, classes. So again, we can use our interfaces to define the shape or structure of a class. And here we just see our clock interface, which simply has a property with a date. So we can use that to define our class. Notice the constructor keyword as well. So we'll see what that does when we compile down to JavaScript. As you can see there, we've just got a JavaScript function there. We've got a constructor in that. Actually, if I just go back. Sorry.
So as you can see, TypeScript is giving us all the benefit of a fully featured object-oriented programming language. You do, yes.
Yeah. As I say, so we're talking about larger applications, building larger applications, and that is going to result in potentially lots and lots of JavaScript code, potentially thousands and thousands of lines. We need to start, we want to organize that down. And one of the ways that we can do that is using TypeScript. So one of the ways we can do that is using TypeScript. And using TypeScript, we get access to another feature, which is the modules. So we can wrap code that we want to expose to our calling program inside a module. We can make various portions of that available, and we do that using the export keyword. So here we want to export our interface, and we want to export our class. So by just marking those as exportable, we then give anything that's using that access to those things. We could also, anything that we don't want to export, anything we want to keep as the internal workings of that module, we simply don't export, and it doesn't become available. So, you want to, anything you'd like to say about this?
Yes, so notice actually here that we've defined a time global variable, which represents our module, and essentially everything inside the module kind of exists against that global variable. And if we had nested modules, or modules separated by periods in the style you might in a .NET namespace, you'd have a succession of nested variables, and you'd be able to access anything inside those submodules using the same period syntax we're very familiar with.
Okay, thanks, Aaron. So what we're going to do now is just very quickly, we're going to run through a very basic demonstration. Aaron's going to do that. And we are going to, I'll just switch you stuff, of course. We are going to take some JavaScript, just plain JavaScript. We're going to start from that point, and we're going to start adding some of those features to it, build it up until what we're left, what we result in is our TypeScript implementation. So, Aaron.
So first of all, we're just going to give some types to this function here. Constrain ourselves to a string type for an input, and it'll return a Boolean. Notice that as we've added the string type to our input, we've got red lines underneath two of our invocations. And the reason for that is the parameter we're passing into the second of these, the one I've got my cursor on right now, it's being passed an integer, or in TypeScript terms, I guess a number. Similarly, like this here is not an integer, this is a Boolean. So this is not a string, it's a Boolean. And so we have the red lines, and if I were to build this, naturally we get build errors. And I understand that this also helps in continuous integration.
Yeah, so we just mentioned before, if we've got a continuous integration build, not using TypeScript, those errors are going to go through essentially. So here, the build will stop at this point. So
yeah, so if you're using
flag us up.
Visual Studio Online, Team City, and you're performing a continuous integration build, if your TypeScript contains errors, then those will be flagged at that stage, and deployment will stop.
Okay, so the next thing that Aaron's going to do is going to define an interface so that we can have some, so we can define the functionality of what he wants to use there. So what have you created there, Aaron?
So just create an interface, iString validator, which is going to encapsulate our new class letters only string validator. Just taking the function we wrote, and we're going to place it inside class. Give it some traditional object-oriented structure. So just as in any object-oriented programming language, we have things that are public, should match is acceptable. Great. And we can also have private member variables as well. But note in TypeScript, if you are using private member variables, you have to use this notation. A bit more verbose than C#. But as we're doing this, note on the right-hand side, it's compiling to JavaScript in real time. So you can see how it's translating our classes and interfaces on the left into code on the right. And so if we want to actually replace this,
so just while Aaron's doing that, one of the, we're actually using a plugin here. It's called Web Essentials. And that plugin allows us to set up so that as we save our TypeScript, it immediately compiles to the JavaScript. So, and we can view the great tool for if you're learning, so you can just play around. I do this in TypeScript, save, that's what I get in JavaScript, that's how it comes down to.
Now, I'm just instantiating right now letters only string validator. That's the class we just wrote. And we're using our validator now and calling our validator to access the same method that we were before, but now we're doing it from a class.
Okay, so thanks for that. So the next stage that we're going to look at some of the organizational feature that we mentioned. So Aaron's now going to wrap this into a module, and so that we can export whatever it is that whatever functionality is that we want to use out to our potential calling applications.
And this is just of course, like as modules in any programming language, it gives our code isolation. It gives our code. It contains our code, and I mean, if many people here have worked extensively in JavaScript, sometimes if you're not careful, you can quite easily write conflicting names between JavaScript files. So we'll just add the validation module. And notice that we've added the module. Whenever we refer to anything inside the module from outside of it, our first table, of course, must export. Refer to anything inside the module from outside of it, we need to refer to the module explicitly. Again, more verbose than C#, if you're familiar with C#, but that is how we do it in TypeScript. You have to provide the fully qualified name every time you invoke something inside a foreign module.
How does the export differ from the private access modifiers?
Okay, that's a good question. So we just asked what's the difference between the export and the public and private access modifiers. So, the export keyword is only really used at the level of modules, I guess. It determines what is visible from outside of the module, whereas the public and private access modifiers are for classes. So it determines what is accessible from outside a class or from inside a class. You get the protected keyword as well, of course. And that helps you if you are performing any sort of inheritance. But yeah, unlike in C#, we have just public, private, internal, etc. In TypeScript, we differentiate whether we're at the level of the module or the level of the class by using either the external or export, or the private, the public keywords. Great.
Just on the module and the export, how does it tie in with ES6?
ES6 does have module functionality, and depending on how you target, how the targeting of your compiler works, you can configure the TypeScript compiler to target ES6. It will use ES6 modules. If you're not using ES6, then it will compile to the form that you see here. And just for everyone everyone's understanding. He just asked whether TypeScript can take advantage of ES6 modules. Cool.
Okay, great. So don't go away because you're
Yep.
going to. So as we can see there, we can see on the right how that's been compiled down into JavaScript. You want to take us through that very quickly?
Yes. Same module encapsulation we saw before. Now, what this allows us to do, of course, and we're not going to do it today, is we can actually separate this into separate files. So you would probably have one file for our interface, we'd have one file for our class, and maybe put some of this other code somewhere else. But you know, I mean, many of us will be object-oriented developers, and organizing a project in this way, it's very natural to us. So there are a lot of benefits to performing front-end development in this very object-oriented style.
Okay, thanks, Aaron. Yeah, that's the end of our first demo. So just to recap, we've taken some raw JavaScript, and we've just started gradually adding things to it. And you can probably see from that it's some of the benefits of TypeScript from the front-end developer's point of view. You start with what they know, and they can just start gradually adding those things. So at any point, any of those stages was valid TypeScript, and they got whatever advantage it may be that they were gaining from using that TypeScript. As their understanding grows, they're using more features and so forth. From the back-end developer, from a back-end developer's perspective, pretty much all of those features are things which are very familiar to us. So it feels more like the kind of language that, as Aaron's mentioned a few times, the object-oriented languages that we're used to developing in.
Thank you for that introduction, Richard. So now that he's kind of covered the bases of the TypeScript programming language, we've gone to the more exciting part of the presentation. So we won't get into model generation just yet. You might have noticed that TypeScript brings front-end development a lot more in line with .NET, with C#. And because of the language features, are so much similar now, it makes it a lot easier to integrate the back end and front end of your application to kind of connect them together. So, so on to the meat of the presentation. Now, because of the fact that that in the web we write our applications in 2 different languages, there is this very uncomfortable interface between the 2 languages where they come in contact, where unfortunately we introduce redundancies, we introduce duplication. They speak 2 different languages, and this causes us all sorts of problems. It gives rise to all sorts of incredibly irritating bugs. And duplication, it gives rise to bugs. When developers have to duplicate code, developers unfortunately make mistakes. So to kind of demonstrate this point, we've prepared another demo for you. And the title of this demo is Richard Brooks' Artisanal Cheese Shop. Now, Richard, I understand that you're quite into your cheese. Is that correct?
Yeah, absolutely, Aaron. Love it.
Yeah. So, so we're going to move on to the demo now. I'll switch over. Great. So if you could just begin by showing us the anatomy of the project.
Yeah, okay, so we've set up this demonstration project. We've got the main model generation web app. We have down here some business logic, and also we have a separate project, and that's quite important to note. This is a separate project for the front end stuff where we're going to keep all our TypeScript.
Yes. So, just to recap, you've got the base web project, which basically just contains boilerplate. You've got all the business logic in a separate project, and you've got a separate front-end project. Now, if you could, Richard, could you start the application, and we can have a look at what we have. Oops. Let me just quickly. I think it's Control Fn.
Okay, so currently this does, well, nothing. We have a search function here, and this is what we're. I'll just click that.
The search function. Oh no. Okay, hold on. We have to go back to our project again, unfortunately, and I think it's saved our.
Let's
rebuild that. Sorry, everyone. Back to that again. So if we go back to it again, I think you'll see that in fact it is not working. We've got an incredibly basic search mechanism. It's so basic that it has no inputs. But that's good for us because it keeps things simple.
Yeah.
We're
Okay.
just clicking, nothing's happening.
Right.
That's exactly what we expect. So we're actually going to fix this now. We're going to fix this by running the code that remains, and that's the connecting code between the front end and the back end of the application. And to start off with, to do this, Richard is going to take the API model from the back end, the one that connects, the one that the search mechanism calls, and he's going to copy it onto the front end. Now, because of the fact that the back end and front end are now in such similar languages, he can literally just copy from the back end, paste into the front end, and make minor modifications until it becomes valid TypeScript. Do I ever get confused whether I'm looking at C# or TypeScript? They're quite similar languages, but they're distinct enough. And for instance, I mentioned TypeScript's incredibly verbose, and that you have to fully specify modules, and it's a sufficiently different language, I think, that I don't personally get confused between the two languages. So what Richard is doing is just giving types to each of these model properties. Now notice these properties are a bit ridiculous. The naming is a bit silly, but everyone knows of API models in real life. They've got dozens upon dozens of properties, and so we're just trying to simulate some of that complexity here by using some scary property names.
Yeah, what would happen if I mistyped any of this stuff?
So if you mistype something, actually, of course, the backend wouldn't recognize the model. The API call would fail. And so it's very important, actually, that we get this right. Now, copying and pasting helps, but there's always a room for error here, so Richard has to be very careful.
Okay, sorry, last one. Which I think was a number. Okay.
Great.
So copy my model across.
Yeah, so now that he's copied the model across, the next thing that Richard has to do is he has to complete the API accessor logic.
Okay, so this is my search products method.
And note, by the way, that we're using AngularJS here, and it gives our front-end application a lot more structure. If you use TypeScript, we highly recommend using AngularJS, as it does complement, they do complement each other very well. This is Angular 1. Now, I'm glad you brought Angular 2. Angular 2 was developed in TypeScript, actually. And I believe it's available for people to use now. But at our company, at BKA, we've chosen for the moment to stick with Angular 1 just because we have the existing developers and the existing tools, existing code to support Angular 1.
Okay. So that's hooked up?
Yes.
What next?
So now that he's written the accessor logic, he just has to invoke it from the search controller, which is being used to, which is basically what gets called when we hit the search button. Now, a promise, of course, is sort of like a delayed response, very common in JavaScript. we're making a request to an API. The API will eventually respond, and when it does respond, we can use a promise to manipulate the result using a callback. And Richard here is just using a dummy model based on the model he just copied across. And he's not going to use any real values. The backend is currently ignoring the values of that model. I mean, of course, the form of the model is important, but the values, these students will know right now. But notice that he's fully benefiting from IntelliSense the same way you would from any typical C# development project. He doesn't have to type out those awful, awful names. And if he did, then we'd be in big trouble and would be here for a long time.
Even longer than you are already. Okay, so.
Great. Now that he's captured the promise, he's going to then use the value that gets returned from the API and send it to the listing controller using the product list broadcaster, which is being injected in that constructor.
Okay, so I'll build that now?
Yes. Now let's cross our fingers. Figure, Richard.
Okay, I'm going to run it now. Just refresh. Okay, so there's our products.
It's working great. So that was excellent, thanks. Let's switch over back to the presentation. So as you just saw then, TypeScript has given us a lot of benefits in terms of I guess, structuring and guiding us to write correct code in binding our front end and back end together. But there are still problems there. There are problems that we haven't resolved. Because when we started this section, I mentioned redundancies, I mentioned code duplication. There is still duplication. We copied across models from the back end to the front end manually. We still have an API specification in the back end and a corresponding specification in the front end. And if those drift apart, we're in the shtuck, basically. We're in the shtuck. So we present now a solution to that problem. And as you may have guessed it, that is model generation. And model generation, you can kind of think of as unifying the back end and front end of your application, even though they're two different languages. With model generation, you could say there's enough crosstalk that you're effectively working with a more of a unified application. And model generation, it really is just reflecting over the models in your backend code, reflecting over those models, and generating from those a TypeScript file containing the same models in TypeScript. Now, as I'm saying this, some of you might be concerned. Okay, suppose I have like a gazillion different models in my backend, right? Suppose I'm automatically generating my models. I have a gazillion models in my backend, way too many for my say I've got a website. I'm concerned about how much people are downloading when they load my application. If I have a gazillion models, and I'm converting all of them, do they have to download every one of my models? Now remember, we went over interfaces at the beginning of the presentation, interfaces don't actually compile to JavaScript. And every single one of those models that you compile from your backend, they compile to interfaces. So you get all the benefits of type safety from that model generation, but you are not impinging upon the experience of your users in your web browsers. So you can kind of think of them as invisible assistants. They provide you with IntelliSense. They give you guidance. If your backend developers change their code to the point where your front-end application ceases to work, and that's indicated by changes in models, that will be flagged very quickly, as we will actually get to very soon. Sorry, excuse me, I just lost my way a bit. But yes, there are actually, we'd like to think of model generation in 3 stages. So you've got build, generate, and repeat. Now the first step, build, basically if you are generating models in your backend for TypeScript, you want them all collected into the same place. And by the same place, we mean both assembly and namespace. So you want all your models exposed to your APIs in a single namespace and inside a single assembly. And it's important that this namespace, because the model generator is not typically very intelligent, it's important that the namespace is clean of any business logic. It only contains models. It can contain enums. Remember, TypeScript has enums, but no business logic, no controllers, just the models, because there can be problems transferring business logic across. The model generator might not know how to do that. So that's the first step. The second step, generate. So once we know where our models are in the back end, and we have collect them into one place, we've built into an assembly, we take a little console app, which is our model generator, and we supply it with some parameters pointing to the assembly. First of all, we point it to the namespace inside that assembly, and we, after pointing to the namespace, we can obviously specify a substitution namespace so that when it's moved to the front end, it has a different module from the namespace it was extracted from in the back end. And finally, of course, we need the output file for our generated models. And the technology which this is based on, the model generator, is something called TypeLite. Now, TypeLite is a freely available technology. It's available on NuGet. Many of you will be familiar with NuGet. You can add it to any project. The licensing is very permissive. Basically, you just have to. If you make a console app with this, and we also supply our own, we'll talk about it later. But if you make a console app out of TypeLite, you'll find that the amount of code involved in building that generator app is very minimal. You're just kind of invoking the NuGet package with some very basic parameters coded into your console app. So finally, we repeat. To repeat, we just take that console app and we take the parameters that we're supplying to the console app, and we insert it into a post-build step on our backend application. So the thing to keep in mind about that is your application is a bit like a production line. It's a bit like a production line because it's important to think about the order in which your application builds. Because in order for your front end to compile, it requires API models. In order for there to be API models, your backend must be compiled first. And therefore, if your front-end code and your back-end code are in the same project, then there is no way that you can compile your back-end, extract models, and then compile your front-end. It's important to separate them out. Very important. Now, you can actually take this a step further. If you have 2 separate teams, a back-end team, a front-end team, and they have different proficiencies, your back-end team is not assumed to know anything about AngularJS or TypeScript, or making competent applications in front-end code, and likewise your back-end developers, your front-end developers, know nothing about .NET, then in this case, it may be important to separate out front end and back end into completely separate solutions. Why do we do this? Because if I make a change in the back end, if my models change, and therefore I influence the front end models, and therefore my front end application breaks, I'm being required to address that break immediately. But if I have it in a separate solution, and the two solutions can see each other via these post-build events, if they can see each other, then it's possible for the back-end developer to defer the repairing of the front-end application until front-end developers become available. So this is something to remember about how to structure your project to ensure that this whole workflow becomes possible, and depending on the team that you have available. So I'm going to actually show you another demo. It's the same demo as before, but Rich is going to do this with the benefit of model generation now.
Okay. So I guess the first thing we'll have a look at that post-build event. Can you see that there?
So the post-build event there, you can see there. I don't want you to worry about that too much right now. We have prepared in the slides a link to a blog post which will detail this for you. So but there's a post-build event. It just points to a namespace. It points to an assembly. It tells you where to put the file and put the outputted models. And if you could show them the API models.ts file, there it is. It looks quite, it's not very well organized, but it's, everything's in modules. It's all the models are there. It's every model from the corresponding namespace in the backend. If you could show them that backend namespace models. There it is. So it's generated the same product search parameters, and the enums as well. It's spotted the enums and it's generated the enums, just product category. And it's generated everything into the API models.ts file. So we're going to do the same as before, but a lot more quickly now that we have model generation, and Richard's just going to basically paste some stuff across now, make everything work. Now, because we have model generation this time, we're a lot more confident in our models. They're correct because it was a machine that saw models in the back end and copied them to the front end. And every time we build our back end code, we have new models. We know our models are the most up-to-date possible. And so we have a very high degree of confidence in the integration of the two parts of our application.
Sorry. Okay.
So because the models already exist in our API models.ts file, Richard is just going to create the API, the connecting API logic. And he's going to use the logic inside the search controller. And if you just rebuild. Great. And hopefully the same outcome. Click some search teasers. Everything just works. Great. Thanks, Richard. So let's go back to the presentation again. So in conclusion, we've shown you today how TypeScript helps you to build better apps by imposing type safety and ensuring better code correctness in your applications. And we've shown you how by bringing TypeScript and your backend language closer together, that being C# and TypeScript's very .NET-esque language features, you can simplify the flow between the back end and front end of your application. And then finally, we've shown you how using model generation, you can really unify the two parts of your application in a very seamless and very satisfying way. And you can try it for yourself, actually. As we promised before, we have prepared for you a blog post which explains, first of all, how you can make your own model generator using the type-like technology we described. We've got our own model generator, which you can download from the same link, which also provides you with any of the necessary post-build commands that you require to run that very model generator. And these slides will be available after the presentation as well. So it's definitely to try for yourself. Our own model generator, we are looking to open source it at some point. It's unfortunately not ready yet. But if you are interested in the code, then please email us. The same email's there. Send us emails. We're happy to help you out. So going on to the next slide, thinking about the future of TypeScript generation, I'm wondering if anyone here noticed something that we missed, any redundancy that still exists between the front-end application and the back-end application, something we haven't addressed yet. So basically, yeah, we've sort of hidden the redundancy of models duplicated across the two parts of the application. But essentially, what we are still missing is, I mean, we still have that duplication between our back-end API specification and our front-end API specification. In theory, it is possible to reflect over all the API controllers in our back-end and then from that, automatically generate API accessor logic in our front-end. Now, this is something just to kind of think about. This is still a work in progress for us, but yeah, definitely something to take away and think about moving forward. I'd like to bring this to our Q&A now, if anyone wants to ask any questions.
So the question was, what's the best way to unit test?
Yes. So we've often had the most success with QUnit, and combining this with AngularJS due to the way that AngularJS provides you with dependency injection. It allows you to use a style of programming according to more solid design principles. It massively simplifies unit testing, and it's the approach that we recommend. Although whatever technologies your company happens to use for unit testing on the front end, what's most important is that your programmers are most comfortable in a certain platform, and so. Against the TypeScript, yes. Any other questions? Hey.
So I'm using TypeScript at work, and something that comes up from time to time is wanting to have some kind of accessor on a TypeScript model, which gives you a slightly different variation of some of that model's content. Do you find, if you're generating the models, obviously you only get the properties.
Yes.
So do you find that is awkward for you when you remove that kind of accessor logic?
So we typically, I guess in our policies, we try to avoid any kind of logic whatsoever in our models. Our models just contain properties, and there might be generics, but any of that kind of logic we try to separate out into more into factories than placing them inside our models, if that makes sense. Does that kind of answer the question?
Yeah, do you use Angular?
We do, yes.
Oh, okay. So say you've got an accessor that you reference from the view and markup.
Yes.
Then would you just move that accessor logic onto the controller typically? Or?
Oh, sorry, I think I misunderstood you. So you're referring to using.
So you don't want to have transformative logic in the view.
Yeah.
Right. So if you don't want to access a property on the model in its raw form, you may want to do some kind of transformation in front of what you usually do and then access it.
So you're saying that, like, for instance, if we were to use directly reference a property that we generated from a model in our view, that would lose the type safety if the model changed.
No, I'm saying like if you put
Okay.
a getter on the model, which
Yes.
had a little bit of logic which gave you a different form of some of the data on one of those properties,
Yes.
to display it the way you want to display it in your view, or get a certain part of that property into your view.
Yes.
And in my experience, we just add like a getter onto the model in TypeScript
Yes.
and just reference that in the view. But if your views are being regenerated, then you can't have that kind of logic in the view, in the model. So where do you put it?
Oh yeah, sorry. In that case, we do put that inside our controller, as opposed to the view model. Sorry.
And that's kind of pretty sustainable.
We've found that pretty sustainable in the SaaS projects we've worked on.
Sorry, there's a question over there. Sorry, so the question was, can we
Typelight.
elaborate on Typelight? What it does for you?
So the Typelight engine is really just the technology which accepts a .NET assembly. Accepts a .NET assembly, and it reflects over a namespace you point out, or multiple namespaces if you prefer, and it generates basically a giant string of TypeScript which corresponds to those models, and that's all the Typelight engine is. And it's quite configurable, it's quite flexible, and it's basically the whole heart of the model generator that we just described. So there's very little code involved in writing one of these model generators of your own. We recommend building your own just because it gives you more flexibility and more reassurance as well. So hope that answers your question.
Yeah, and as I say, we're happy to share our code
Yes.
at this stage, like with you if you're interested in that. At some point, we'll make that fully available, but we just need to tweak some stuff first before we make that available to the
Yes.
public.
Any other questions?
Have you ever had that output of that generation process actually going directly into files which are included in your solution structure? Or do you always copy and paste afterwards?
We typically generate into a file that's, the way we store it in a repository, first of all, we'll have a file that's kind of missing, but is referenced by the project. And when the backend builds, the file gets generated, it populates the missing file in the front end, and so it's part of the solution, if that makes sense.
But we'd leave those generated files out of our repository in the first place. So
Yes.
we'd never commit those because they'd be built as part of our continuous
And
integration.
they create all
process.
sorts of merge conflicts, unfortunately. So
But they are part of your compile approach.
yes, yes, they are. Are there any other questions?
Okay, thank you very much. That concludes the presentation. Thank you.